All right, so in this video, we're going to be dealing with applications of implicit differentiations to finding equations of tangents and equations to normals. So let's start with the first one. Determine the equation of the tangent at the point 1 and 1. So we've got an implicit formula here, so we then have to implicitly try and differentiate this. So let's start with the first one. So this will be 6y squared. This will be dy dx. Plus, we'll take the product rule here. So differentiate the first term, which is 4, keep the next. Plus, keep the first term, differentiate the second, which is dy dx. And then the derivative of x squared is just 2x. And the derivative of 7 is 0. So what we want to do is keep dy dx as subject of the formula. So let's go. We left with 6y squared dy dx plus 4x dy dx, and then we'll take all the other terms to the other side, minus 4y minus 2x. And what we want to do is keep dy dx as subject to the formula, so we left with 6y squared minus 4x. So let us continue with that. Minus 4x, and then from here we now can go minus 4y minus 2x, and then we will take that and make that subject to the formula, so we can explicitly say the expression for the derivative is minus 4y minus 2x over 6y squared minus 4x. All right, so what we then going to do, we have to sub in our point of contact, and our point of contact is 1, 1, in order for us to explicitly find what that expression is. So our derivative is now going to be, we have to substitute 1 wherever we find x. So this is 6, 1 squared minus 4. And then let us try work out what that gives us. Minus 4 minus 2 gives us minus 6. And then 6 minus 4 gives us, 6 minus 4 just gives us 2. And therefore, the derivative of this is just minus 3. So remember that this equals to the gradient of the tangent now. So the gradient of the tangent equals to minus 3. So therefore, if we are finding the equation of the tangent, it will have a gradient of minus 3 and plus c. We then also come in and sub in the point of contact, which is 1, 1. So this becomes 1 equals to minus 3 times 1 plus c. And if we take that across, we easily get that c gives us 4. So therefore, the equation of the tangent is given by y equals to minus 3x plus 4. And that is the solution that we get. What a good application question. Let's deal with the next one. The next one says determine the equation to the normal at x equals to pi over 4. So with this question, we'll just start by simplifying the question first. So this becomes the ln of the tan x to the half, and therefore this is just equivalent to saying, using our log rules, this is equivalent to saying y equals to a half of the ln of tan x. So that is the expression that we have. So the first thing we want to do, we want to work out our point of contact. So the point of contact when x is equals to pi over 4. So this means that y is going to equals to a half of the ln in brackets tan of pi over 4. And if we do that, I think we can simply get that this gives us the ln. So this is half times ln of 1. But ln of 1 is 0, 0 multiplied by half gives us 0. So the coordinate of our point of contact now simply becomes pi over 4 and 0. Now let's try work this out. So now on the other side here, we'll get dy dx. And then I guess you've also guessed this right. If we are trying to find the derivative of this function, we'll now have a half. And this becomes the derivative of tan of x. So remember, according to the rule for tan x, we'll have tan x at the bottom and then have the derivative of tan x in the numerator equaling to 0, and then we'll take everything to the one side. So now this ends up giving us a half times sec squared of x over the tan of x. So now remember, we just want to find the derivative of that, so we will sub in our point of contact, which is pi over 4 and 0 wherever you find y, or just sub in pi over 4. So dy dx of this gives us a half over the tan of pi over 4 times the sec squared of pi over 4, and this gives us a half, and this gives us the square root squared, because tan of pi over 4 is 1, so therefore our final answer will end up being 2 over 2, which is just 1. So what this then means is that the gradient of the tangent is equals to 1. So therefore what this means that the gradient of the normal, because the normal is perpendicular to the tangent, will be minus 1. So therefore we'll sub this into our equation, y equals to minus x plus c. We'll then go in and sub in our point of contact, pi over 4 and 0. So we now have 0 equals to minus pi over 4 plus c, giving us that c equals to pi over 4. So therefore the equation to the normal at that particular point, equation to normal, will be given by the equation y equals to minus x plus pi over 4. Bam. I hope this has made sense, and this is like a very good question to do, and exam type even, and I hope this has made sense, and therefore I'll see you in the next video.